Now we can see some sample problems related to the free fall motion. The first one here, a ball falls vertically from 100 meters. Find A, the time for the ball takes to fall for the first 50 meters. B, the time of the ball takes to reach the ground. C, the speed of the ball as it hits the ground. This ball has an initial height 100 meters. So this is the initial height. And it's accelerated by the gravity, and the magnitude is 10 meters per second square. So if the ball has moved t second, the speed of the ball here becomes g times t, or 10 times t. Now we can calculate the distance traveled by the ball here. So since this falls with the zero initial speed, so the distance will be the final speed 10 times t. We multiply by time, divide by 2, so that we get 5 times t squared. Now if the ball has traveled 50 meters, so the distance here is 50 meters, we can calculate that 50 is equal to 5 times t squared, so that the time square is 10, or the time needed for the ball travels 50 meters is square root of 10 seconds, so it's around 3.16 seconds. Now the second question is, we are to find the time for the ball to reach the ground. So here you see that the distance traveled by the ball is 100 meters. So we can also use the same relation here, so that the t square is 20 and the time needed for the ball travels to the ground is the square root of 20, and that's around 4.47 seconds. So you can compare that the time needed for the first 50 meters is larger than the time for the second 50 meters, and that's around 1.31 seconds. Now we come to the last question here. That's the speed when the ball hits the ground v. So as you already calculated, the time needed for the ball reach the ground is 4.47 seconds, and it's accelerated by the gravity g, and the speed here becomes g times t, or 10 times t. So you get that the speed when the ball hits the ground is 10 times 4.47, or 44.7 meter per second. The second problem, a ball falls vertically from 100 meters, so this is actually similar to the first one, but now the ball has initial speed 20 meters per second downward. Find A, the time the ball takes to reach the ground, and then B, the speed of the ball as it hits the ground. So in the second problem we have a little bit different situation. Here the ball has an initial speed 20 meters per second and it accelerates by the g, or 10 meters per second square. And as you know, after it moves t second, the speed here will be the initial speed of the ball 20 plus the increasing speed. Here is the gravitational acceleration g times t. So we can find the distance traveled by the ball, but if it has initial speed here, we must include in our calculation. So this is the initial speed times the time plus the final speed, 20 plus 10 times t divided by 2. So you already learned this previously in the constant acceleration motion, and we get that the distance traveled by this ball is 20 times t plus 5 times t square. Alright, now the ball will travel to the ground, and the distance to the ground is 100 meter. So here we can put this number 100 meter, and it's equal to 20 times t plus 5 times t square. So you get 20 is equal to 4 times t plus t square. And here we get the quadratic equation, t squared plus 4 times t minus 20 is 0. And by solving this equation using, for example, ABC formula, you can get that the time for the ball travels to the ground is around 2.899 seconds. Now the last question of this problem, we are asked to find the speed at the ground. And as you know, if the ball has traveled t second, or in this case the t is 2.899 seconds, so the speed will be 20 plus 10 times 2.899, or you get around 48.99 meter per second. This is the third problem. A soccer player kicks the ball vertically upward, so it gets an initial speed 30 meters per second. So we are asked to find first the maximum height reached by the ball, and then B, the speed and the acceleration at the maximum height, C, the speed of the ball after 5 seconds, and then D, the time that the ball needs to return to its starting position. And then finally we are asked to draw the speed versus time graph. So now we come to the last problem, the third one. Here the soccer player kicks the ball vertically, so it has initial speed 30 meters per second. So in this case, the ball decelerates, or the speed will decreasing because it's attracted by the gravitational acceleration g. And you know the value is 10 meters per second square, meaning that every second the speed will be decreasing 10 meters per second. So for example, when t is 1 second, the speed will be 20 meters per second, and when the time is 2 seconds, then the speed will be 10 meters per second. So you can predict that eventually at 3 seconds the speed will be 0, or it gets the highest or maximum point. Here you can also find the time to get the maximum point, and that's just the initial speed 30 divided by the gravitational acceleration 10, and you get 3 seconds. Now we are asked to find the speed and the acceleration at the maximum point or the highest point. So at the highest point, the speed will be 0. But the gravitational or the acceleration is still the gravitational acceleration, or it's around 10 meters per second square. So that's the acceleration. Right. Now we are asked to find the speed of the ball after 5 seconds. So let me draw again our situation here. The ball has initial speed 30 meters per second, and after 3 seconds the ball gets the highest point, and that means at 5 seconds the ball already moved to the downward. So for example here 5 seconds, and you know that the downward motion is still under the gravitational acceleration, so it accelerates the motion by 10 meters per second each second. So 5 seconds here is 2 seconds after the highest point, and you know that the speed at the highest point is 0. So after 2 seconds from the highest point, the speed here will be 10 times 2 seconds, so it will be 20 meters per second. Now we are asked to find the time for the ball to return to its starting position. Alright, so when the ball travels upward, it will take 3 seconds to the highest point, and when it's moving downward, it will take another 3 seconds to get the same position. So that means for traveling time here, the total traveling time here will be 6 seconds to return to the starting position. Now the last one, we are asked to find the speed versus time graph. Alright, if we plot here speed and time, in this case we have initial speed 30 meters per second, and after 3 seconds it will get the highest point, and the speed here is 0. So this is the speed versus time in the first 3 seconds, or the upward motion. And then in another 3 seconds, or until 6 seconds, the ball will gain more speed, so eventually it will have a same speed here, 30 meters per second, as the initial speed. So if we plot the speed after 3 seconds, it will be like this. So this is the speed versus time graph for the motion of the ball.